Now, our third method of solving systems of linear equations is called elimination. Honestly, guys, this is the one that if you were to ask math teachers what they use the most often to solve systems of equations, this is the one. It's probably the fastest. It just takes a minute to kind of get your head around what it is that you have to do for it. But ultimately, it's kind of like what we did with substitution in that we would like to be able to only have one variable to solve for. But in order to do something like that, you have to eliminate one of the variables. And so solving a system of linear equations by elimination is sort of what we're allowed to do. Now, when we talk about eliminating a variable, we're adding opposites. So we're taking positives and negatives of any of the same value, adding them together and making them zero so that they go away. Now, I want to show you something. And actually, this is not something that's on the actual sheet themselves. So I want to show this to you kind of, we'll say like off on another page here to show you why something like this works. Because I think one of the things we run into as a problem is that sometimes it's hard to understand what the heck it is that we're looking at. So let me just show you something really quickly. Generally, I do this in class, but we're not there right now. So what I want to show you is the way kind of equations will work. So I'm just going to give you really quickly, let's just do a couple of additions. Let's say 2 plus 7, we know that is equal to 9. Okay, so we have a math equation here, very simple, kind of has us work through this. I'm also going to do one with a subtraction because why not? Let's go 12 minus 6 is equal to 6. Now, what I have right here are pretty straightforward problems. Like none of these are really an issue. What I always do is kind of make this like it's a math magic thing that's happening in class. You go, let's show you what's going to happen. What's really cool is that the way math works is that if I take this and create a new equation out of these two by just taking them and adding straight down, what we should get is an equation that is also true. So let's just add straight down. 12 plus 2 is going to give me 14. Okay. Positive 7 plus negative 6. Well, those will work with each other like they're subtracting. So the 7 minus 6, that'll give you a positive 1. And then 9 plus 6 is going to give you 15. Now, 14 plus 1 clearly does equal 15. Should work just fine. Now, I can do this. What I tend to do in class is to say, give me random numbers and let's figure out what they're going to be. I'm going to give you a hint. This always works, and I'm going to show you why really quickly, but let's just kind of go through another one. Let's say 19 plus 7 is equal to 36. Am I doing that right? 19 plus 7 is equal to 26. Guys, been a long time. Just so that you know, I make mistakes. You're going to do fine. And then let's go 14 minus 3 is equal to 11. Okay, you can literally do this with any numbers. It's going to be fine. But what we should be able to do, if we add these together again, everything should work. So 19 plus 14 is going to be 33. 7 plus negative 3 is going to be 4. And if I add 26 plus 11, it's going to give me 37. Bam. It absolutely works. Now, it's not hard to show you why it works. It's because it's an equation, okay? Equation means two things are equal. So this looks magical when we add straight down, and you can you trick your parents, they'll be like, what? And you can just show them this. It works always. But if we look at something like this, if I take what this equation actually says, it's saying, well, this is just 9. 9 equals 9, and in this case, 6 equals 6. So if I add those together, it's not hard to say that 15 is equal to 15. It's just that the stuff that I had on the left-hand side here was broken into two pieces for each of them. I added all of those pieces together. So I'm taking 9 and 6 together, even though they're in broken pieces. When we're together, it will be 15, no matter what they were to start with. It's the same thing here. Both sides of this are 37. This is 26. If I took 26 equals 26 and 11 equals 11, if I add straight down, it's going to be both of them being 37. And the reason that it works is because this is all you're doing. An equation is saying that the thing on one side is equal to the thing on the other side. This here is just a representation of 26. This here is a representation of 11. So when I add them together, it doesn't even matter. I could add diagonally. I could put these two together and these two together. I'm putting all of the parts in one pile, and that pile is going to be the same as what I'm doing here. That is the way that equations work. As long as you're talking about two things being equal and two things being equal, if you add straight down, you will always get two things that are equal no matter what. Now, that is nice for like a little parlor trick thing like this, but it generally doesn't come into play when you're going to be doing actual work until we're solving systems of equations. Because when we have opposites like these that exist in systems of equations, if we add two equations together, we can identify something that's an opposite and make that thing go away. So we will only have one variable to solve for. And then when we solve that, everything else falls out. And that's the reason why I want us to look at something like this, because as we do this math, when you have a system of equations, I mean, first off, neither of these is set up to use to graph. Neither of them is set up to do substitution. We'd have to do work to make any of that happen. So what you're looking for is to see, do we have any opposites that if we combine them, we will eliminate one of the variables? And in this case, I have a positive 4x and a negative 4x. And that's actually my first step, is look at your system and see, do you have opposites of one variable? We clearly do. I circled it out here. What we then do is use what we just looked at with those numbers there and just add our two equations together, because our new equation is going to be something that has to be true. If you add things together that are equal to other things together, and as long as you're being consistent with your addition, you will have two things that are equal to each other, and that's what we're looking at here. In this case, the equality means that we will make one of the variables go away, and now we're solving for one variable. So when we look at this, because I have clearly two variables that will cancel each other out, if I add straight down my columns, 4x and negative 4x, that is a 0. There is no more x on this problem. It's gone. 3y plus 2y is going to give you 5y, combining my like terms. 17 plus the negative 2 gives you 15. I now have an equation that doesn't have an x in it that is super easy to solve. 5y equals 15 is a one-step equation. All I got to do is divide both sides by that coefficient 5, and I'm going to get 3 as my answer for y. That's what's great about the elimination thing, is if you have opposites, all you got to do is put them together, make one of them go away, and I can solve for that other variable. And then it's just like it was for substitution. I take that variable now that I know, plug it into one of the equations that we had from the original. And I've got two equations to plug into. I can plug into either one of these and it's totally fine. For me, I generally choose the one that has less negative numbers. And that's what I did in my example down here. But ultimately, you take your value for 3, you plug it into whichever equation works, and I use the top one, but you could do the bottom one. You'll get the same answer. Plug it in, evaluate it. And so here I plug the 3 in for the y. I can do the math. Now I subtract the 9 from both sides, and I get that 4x is equal to 8. If I divide both sides by 4, I get my final answer is that x is equal to 2. Just like we did with substitution, I have an x value, I have a y value. So when I am done with this, my solution to this is going to be 2, 3, my x and my y. Now, I have all of these steps here, and you're going to have this version as well to be able to look at. I want to take you through at least one more example to show you, hey, this is going to be a little bit different, and I want to make sure that you can kind of pay attention to it. So for this, I'm going to go to the next page for this. And I think to do this, I'm going to do the first example, and I'm also probably going to do the third example just to make sure we kind of get a little space here to be able to work with it. Should be fine. I'll do the middle one and have it done on my completed notes, but it's not something that you need to be able to actually see in front of you to see how it's going to be done. So again, first thing that we want to do is identify, do we have opposites? Clearly right here, we do. We've got a negative 3y and a positive 3y. Perfect. Set up perfectly for us to use our elimination by adding straight down and keeping these equations equal. So 5x plus 2x is going to be 7x. Negative 3y plus 3y, those will cancel each other out and give us a 0. Now, I'm not going to write it because it takes up too much space and time. I'm just going to keep it here where 7x is equal to 29 plus 20 is 49. I now have an equation. Y is gone. 7x equals 49. I am one step away from solving for x because it's just a number in front of x is equal to a number. Take both sides of this, divide by 7. This will cross out. We will get that x is equal to 49 divided by 7, which is 7. So our first value has been solved for. Now, legitimately, guys, you can plug this into either of these two equations. I used the top equation the last time. For this one, I'm going to use this equation. And I just kind of tend to write it here. This is the variable I now know. So I go back into this equation, rewrite it, and wherever there was a variable, I'm going to replace that with parentheses. Everything else is here. So that when I'm done, it's just like what we did when we did the substitution problems before. You substitute this value in, it's right there. Now we're just doing some math. 2 times 7 is 14. 14 plus 3y is equal to 20. Now, if I subtract 14 from both sides, this will go away. And I'm going to get that 3y is equal to 6. And if I divide both sides of this by 3, I'm going to get that y is equal to 2. So my final answer for this problem when I'm done with it now is 7, 2 as the solution to this system of equations. Now, some of them take longer, some of them take less time, but ultimately it's find your opposites, add them together so they become 0, and then when you're done with that, plug in your answer into the other equation, okay? I want to show you something that will probably come up, and that's a situation like problem 3. If you look at this, we don't actually have opposites, okay? I don't have an opposite from the top to the bottom here. Now, these are the same. They both have 4. So you can add both of them. It's always easier to do the addition. Adding is always easier than subtracting. But ultimately, if you would like to, you can do this as a subtraction as well. It's fine for us to do that. And when they're exactly the same, that's what I tend to do. There's another thing we're going to be learning about in tomorrow's lesson that has to deal with how you deal with this when the numbers are different completely. And it's similar to the idea of subtracting. It's like it's an equation, so we can multiply both sides by this. But anytime that they're just exactly the same, what I do instead of addition is I'll put a subtraction sign out here on the side, because if you have two things that are equal and you add them together, those will be equal. If you have two things that are equal and you subtract them, as long as you're consistent, you'll be fine. But just remember, when you subtract, it's top minus bottom, so that your result might be negative as we're working through it. It's fine, just be aware. 4x minus 4x cancels out, it's gone. 5y minus 8y is going to be a negative 3y. And if I do 22 minus 28, I will end up with a negative 6 because I'm taking more away than I had. So now it should be pretty straightforward. Same thing as the last time. I divide by that coefficient. If I divide by negative 3, I'm going to get in this case that y is equal to 2. Now it's exactly the same thing that I did the last time. Pick an equation, and it really doesn't matter. I'll do the top one because there it is. Plugging in the y for the 2, so we know 4x plus 5, put parentheses for y, is equal to 22. Then now I will substitute that 2 in for the y because I just solved for it. And now it's time to do your math. So we got 4x plus 10 is equal to 22. If we subtract both sides with that 10, cancels out here, and I'm going to get that 4x is equal to 12. And now if I divide both sides by that 4, I'm going to get that x is equal to 3. Now, the only thing I would suggest doing on this one, when you write your point, just remember you're putting them in order. 3 is your x value, so that goes first. 2 is your y value, so that goes second. That is the solution to the system of equations. And that's the last example we're going to go through for this set of notes. So that should be enough. Please go through and make sure that you can do these on your assignment.